So Jan 2018, Unit 6. We did the first two questions, so I will solve the remaining question 3 and 4, and then I'll discuss the doubts from Unit 4. Question 3 is a student use a light meter to investigate how the light intensity from a filament bulb vary with the distance from the bulb. State precaution that she should take to measure the uh, to make measurement of a light intensity as accurate as possible. So if you want to measure the light intensity accurate as possible, because what you should have, like there should be no other source in the surroundings. Otherwise, because investigating the main experiment is investigating using a light meter, investigating how the light intensity from a bulb vary with the distance. So the bulb should be the only, there should be like bulb should be the only source of a light, or there should be no other light source. Student use the distance in the range 5 centimeter to 80 centimeter. Explain with the aid of calculation why a meter rule is suitable for measuring. So why meter rule is suitable? Because the maximum which a meter rule can record, that is 100 centimeter, one thing. And the second thing, when we work out the percentage uncertainty, like how to work out the percentage uncertainty is uncertainty divided by value recorded into 100. So the percentage uncertainty, if we work out for this one, the highest value will have a smaller percentage uncertainty, because percentage uncertainty is uncertainty divided by value recorded into 100. So if we record a higher value, it means it will have a lower percentage. So it is obvious that 80 centimeter will have lower percentage uncertainty than 5 centimeter. So we'll work out how much is a percentage uncertainty for 5 centimeter. So percentage uncertainty is uncertainty for a meter rule or a meter scale, smallest which we can record is 0.1 centimeter divided by 5 into 100. So this will be 10 divided, so this will be 2%. The 2% is a very small percentage uncertainty, because it's if the value is high, like example 10, 15, then it will lead to an error, but 2% is a very small value, so it is acceptable. So one thing you can mention, because maximum it can measure 100 centimeters, so both values are less than 100, and the second thing you will compare with a percentage uncertainty. Then student think that the light intensity vary with the distance from a filament according to equation I is equals to k d raised to power minus 2. Where k is a constant, she measure a distance and record some corresponding value for I as shown in the table. Explain whether these values are consistent with equation, and your answer should include a calculation. So you have to show by calculation that they're consistent. So basically k is a constant. So what we will do, we will substitute the value, like we'll find the value of, if I simplify this equation, it will be I is equals to k d raised to power minus 2, or I d raised to power minus 2 is equals to k, or it will go there in numerator. So it will be d square I is equals to k. So we'll substitute the value of d and then square it, and we substitute the value of I and then multiply them, we'll get the value of k. How we know that they're consistent? Like for each set of a result, we should have a comparable value of a k. We'll find a value of k for the first set of results, second and third, and we compare these values. If these values are like percentage difference between the maximum and minimum is less than 10%, so we'll say the values are consistent with the equation. If the percentage difference is very high, then we'll say the values are not consistent. So you just have to find the value of a k for each set of a result and then compare the values. Sometimes it looks like the values are approximately same, so you don't have to calculate percentage difference. But if you're not sure of the values, better calculate the percentage difference. In question 4, a burette is filled with a liquid and allowed to empty by opening a tap. An investigation is carried out to determine a relation between a volume of a liquid remain in the burette and the time for a liquid to fall from 0 mark. So state the property of a liquid that determine the rate at which it flows. So we call that as a viscosity. Viscosity is a property of a material which decide how much time it will take to flow. Suggest one advantage of opening a tap with initial liquid level above 0. So what might happen if the initial liquid level is above 0 and we open the tap? The advantage is that we can have a time to react to it. That's like we can start the moment we open the tab, we don't have to start the timer. The moment we see that it is about to reach 0, that time we'll start the timer. So it is whenever, like example, you're reading two values simultaneously or using two operators simultaneously. Like example, looking at the level and then start the timer, that will have a uncertainty because like where you will take time to react, like opening a tab at the same time of starting the timer. So one advantage is that we don't have to start the timer and the tab together, like open the tab and start the timer together. Just we open the tab and wait until it reaches 0 and then we just start the timer. There will be reaction time in that, but we don't have to use like switch on the both operators or both devices twice, like simultaneously. It is suggested that V is equals to V naught e raised to power minus BT, where V is the volume of a liquid remain and V naught and V are the constant. Explain why a graph between V and T should be a straight line. So we have V is equals to V naught e raised to power minus BT. We take ln both sides. So it will be ln V is equals to ln V naught e raised to power minus BT. When two quantities are multiplied, we write them in addition in ln. So we'll write ln V naught plus ln e raised to power minus bt. Ln and e are anti-functions, so they cancel out each other. So ln, we'll say ln V is equals to ln V naught minus bt because e and ln cancel out. But because we are plotting time on x-axis, so it should be after the equal to. So if we rearrange the equation, we can say ln V is equals to minus bt plus ln V naught. And then we'll compare with the equation of the straight line. On y-axis, if we have ln V, on x-axis, if we have t, what will the gradient? Our gradient will be minus b. Means somewhat the graph between ln V and t should be a graph with a negative gradient. And why it should be a straight line? Because b is a constant. So whenever a constant is involved in a gradient, it means it must be a straight line. And it's a negative minus b is there, so it means that it is a negative gradient, negative value of a gradient, not like gradient is decreasing. It means the value of the gradient will be negative and constant. And then the y-intercept, when we work out the y-intercept, so y-intercept will give us ln v naught. It's the same like graph which we normally have for internal resistance batteries with internal resistance. The following data was obtained for this investigation. You just have to plot a graph, but before plotting a graph, you should have like ln v is there, and you will get the values. Then they determine the value for b. So shape of the graph will be somewhat like this, and then you will find the gradient, and negative of the gradient will be equal to b. So this was the last question from Jan 2018.